Today we are going to do section 9.1 on page 822, Trigonometric Identities. Now we already know one identity, which is called the Pythagoras theorem. Okay, it comes from this thing right here, which says that if your hypotenuse is 1, which means this is on the unit circle, the unit means 1. If the hypotenuse is 1, then the opposite side is called sine t, and the adjacent side will have the value of cosine t. And then the Pythagoras theorem states that the sine t squared plus cosine t squared equals to 1. Okay, and that's the Pythagoras theorem in trigonometry. So we can, so that is our very first identity, which is sine squared plus cosine squared equals to 1. Now this identity can be rewritten if you divide by either sine squared or cosine squared. If you divide by sine squared, let's say we'll divide by sine squared here, okay? And then this will also be divided by sine squared, and then the 1 will also be divided by sine squared. If we did that, this will become 1, right? And then this is cosine over sine. Cosine over sine is called cotangent, okay? That's because tangent is opposite over adjacent. So then, actually maybe I should write this down here. Tangent is also equal to sine over cosine, because it's opposite over adjacent, and opposite sine over adjacent is cosine. So this is tangent also equal to this, okay? So the cotangent, which is the 1 over tangent, will be flipping this over, will be cosine over sine. So this thing is actually the cotangent squared t. And then this will equal to the 1 over sine, 1 over sine is called cosecant. So that equals to 1, this equal to cosecant t. Okay? So then, and remember the square here means the whole thing got squared. We're just too lazy to write parentheses and all that stuff, so we'll just put the square here. It means the sine of t, the whole sine of t got squared. So anyway, this is one other different formula. There's a square here, okay? And then that's one thing. Another one is if we write down the same, sine squared plus cosine squared equals to 1 on the other side. So if you write this thing down, then last time we divided by sine squared. If we were to divide it by cosine squared t, this also divided by cosine squared t. And the last one is also cosine squared t. What we get is sine over cosine is a tangent, okay? Because by this definition and this graph. So sine over cosine equals a tangent. Maybe I should write a t here. All right. So then sine over cosine is equal to tangent. So this is tangent squared t. And then cosine over cosine equals to 1. And then this equals 1 over cosine. 1 over cosine is secant, okay? Secant is turning cosine upside down. See, so 1 over cosine is equal to secant squared. And that is our second formula. That is the same thing as the original formula, which is sine squared plus cosine squared equal to 1. And it just depends on whether you're dividing it by sine squared or dividing it by cosine squared. Then you get these things that look somewhat different, and sometimes they're useful, okay? Most of the time, I just, it's not necessary to memorize these things, because when you need them, like if you see tangent squared, and you're trying to remember the formula involving tangent squared, then you just write down the sine squared plus cosine squared equal to 1, and then make it into tangent by dividing by cosine squared real quick. Okay, then you look at this formula and you recognize, oh, that is tangent squared, that is just 1, and that 1 over cosine is secant. So that's secant squared, and so the formula involving tangent squared will be tangent squared plus 1 equal to secant squared. And is the same way over here. And so these are basically come from the Pythagoras theorem. It just But sometimes they might be useful because all you see in your formula is a tangent squared and you don't see sine or cosine anywhere. So this might come in handy sometimes. But most of the time, we only care about one thing. Is sine squared plus cosine squared equals to 1, which is the Pythagoras theorem. So that is that. So please turn to the next page, page 823, where your books also prove the same thing rather differently. Okay, that is not because they're wrong. There is more than one way to skin the cat. So please read through what your book did and try to make sense of it. And the way your book does is a bit longer. This is this is a much faster way, to remember it. That is, when you need to remember what was the equation involving cotangent squared, then you just make cotangent happen. Cotangent is cosine over sine. Because cotangent is flipping tangent around, and tangent is sine over cosine. So anyway, so please read that yourself, and then we'll look down at the middle of the page. I'm still on page 823. In the middle of the page, we have the odd-even functions. And now, as you can see, cosine is the even function, okay? And we'll write down the e here. And should I write down the e here? Maybe that's confusing. I think I'll write down the e outside. So cosine is an even function. Even function means if you stick a negative sign inside the cosine function, it's as if you didn't do anything at all. Okay, cosine of negative theta equals to cosine theta. So the negative sign you can just throw it away, basically. So this is the even function. Okay, and because cosine is even function, secant is also the even function. And we'll write the e here. And that's it. These two are the only even functions. Every single thing else is the odd function. What that means that if you have a negative sign inside, you have to take you have to take it out. That is, and if you want to get rid of the negative sign inside the tangent, you can, but you have to leave it outside. See, so tangent negative theta equals negative tangent theta, and the same as sine and the cotangent and cosecant and yeah, all four of these things, you have to take the negative sign out. Only cosine and secant, being the secant is 1 over cosine, so they work the same way. Only cosine and secant has the quality of, if you slap a negative thing in there, then you might as well, it's like you didn't do anything at all. And you can just throw it away, like it didn't happen. So that is the even odd situation. So yeah, well, I guess that might be tolerable. I'll write it maybe like this so that it doesn't look confusing. Anyway, yeah, so anyway, cosine and secant are the only even functions out of the 6. Everything else is odd. So having said that, let's turn to the following page. Let's see. Okay, and the next page we have the reciprocal identities, which we have already mentioned. Okay, that is sine equals to 1 over cosecant, or cosecant equals to 1 over sine. I'm looking at this chart right here on the following page, on table 3, I guess. Yeah. Anyways, so that is what we have already mentioned. That is, sine is 1 over cosecant, or cosecant is 1 over sine. Cosine is 1 over secant, or secant is 1 over cosine. And tangent is 1 over cotangent, and cotangent is 1 over tangent. And the way you remember it is write down sine, cosine, tangent, cotangent, secant, cosecant, following this U shape. And then whoever goes across, they are reciprocals of each other. That is, each one is 1 over the other thing. So that is how I memorized it. But of course, use whichever method of memorizing that works best for you. All right, and specifically, tangent is equal to sine over cosine. Okay, and cotangent is flipping that around. That will be cosine over sine is the cotangent. So that is that. And then let's look at example 1. What is example 1 want? That now I'm on page 825. I should write that down. We're gonna skip example 1 because cotangent theta is 1 over tangent theta. So I don't know what they're talking about. Okay, if you graph it, they're the same. So let's ignore that and move on to example 2, where we do our very first trigonometric identity. That's on the following page. So let's look at page 826, example 2. We're supposed to prove that tangent theta times cosine theta equals to sine theta. So let's write that down. So how do we prove that tangent theta times cosine theta equals to whatever? Now tangent theta is equal to, from here, tangent theta is equal to sine theta over cosine theta. That you do need to memorize, okay? And so, and you memorize it from this graph, okay? Opposite divided by hypotenuse is the tangent. So sine theta over cosine theta is equal to tangent theta. So let's write that down. So this is sine theta over cosine theta. Now the thetas are Greek letters, okay? They are no better and no worse than English letters. So do not be threatened by seeing a Greek letter. It just pretend it's T or something. Anyway, so sine theta over cosine theta, and then that's tangent theta right here, times cosine theta, and that's that one right here. So we have two of them that cancels out. So the answer is just sine theta, and that's it. And as you can see in the book, that is correct. Okay, so that's example 2. So next, let's look at example 3. Example 3, all right, let me write it down. Now here is example 3 on page 827. We have 1 plus sine x and 1 plus sine of minus x. Whenever you see a minus inside, let's get rid of it somehow. Either take it out or something. And so consider the rules for taking stuff out. Now the cosine function is and plus is reciprocal secant function are the only even functions there are where you can just throw the negative sign away. It doesn't hurt anything. All the other functions such as sine, if you take it out, you have to slap it in front. So that's what we're gonna do. So this is equal to 1 plus sine x and times 1 minus sine x, because we have to, being the sine is an odd function, when we take out the negative sign, we have to put it in front of there. Now that will become, so that is equal to the difference of squares. Remember difference of squares, which states that a squared minus b squared equal to a minus b times a plus b. Now this is something you need to memorize, okay? Please write this down in your cheat sheet if you don't know this already. And this comes very handy in this course and beyond. So anyways, this thing called difference of squares. Now you notice that this is a plus and then a minus situation, just like here. So the answer is just this. Or you can multiply the whole thing out by hand. That's fine too. But we're just going to write this out. So this is 1, the first squared minus the second thing squared, minus sine x squared, which we write it like this. And what is 1 minus sine squared? Remember that sine squared plus cosine squared equals to 1. So 1 minus sine squared x, it will be equal to cosine squared x. The reason is because sine squared, if you put it on the other side, that becomes a plus. Sine squared plus cosine squared equals to 1, according to this triangle. And so that is the right answer. Okay, so let's look at the next example on the same page, example 4, which states that we need to verify. Now we're going to work on secants. So we have secant squared, oops, let me write this down. All right, so we have, this is the problem we have, okay? So it's secant squared theta minus 1 divided by secant squared. So we're going to break it into 2 parts. So the fraction, okay, with the first one, so this equal to, the first part is secant squared over secant squared, which is just 1, minus, and the second part is 1 over secant squared. Now 1 over secant is cosine, so that would be 1 minus cosine squared theta. Okay, and 1 minus cosine, what's 1 minus cosine? Remember that sine squared plus cosine squared equals to 1. So 1 minus cosine is going to be equal to sine squared theta. And that's the, because if you move the cosine on this side of the equation, it becomes cosine squared plus sine squared equals to 1. So that is the answer to this, to this thing. Unless No, that, let me see. And I want to make sure that, yeah, there is, that seems okay. And that is also what the book says as well. The book went through a more complicated way of doing things, and then, but also agreed that the way I happen to choose is correct. And you might think, which way are you supposed to choose? Pick whichever way you want. Doesn't really matter. When it comes to proving trig identities, there's usually more than one way or two ways to skin the cat. Just yeah, and please go through the book's way of doing it. I'm not going to go over this, but it's explained very clearly, so you see how they did it, okay? Because sometimes you might have to go through a more roundabout way of doing things. Those are all just skills that is good to learn in order to manipulate trigonometric identities. And that is, trigonometric identities is probably one of the most useful parts of and important parts of trigonometry. So I would like you to do as much of it as possible and be as good of it as you can. Let's see, yeah. So that's why I recommend that you read the first part, the first method yourself, okay? And then we are going to move on. So let's next look at example 5. Okay, let's see. I think I'll clean off the board first. So next, let's do example 5 on page 827. Our problem is 2 tangent theta and secant theta. We need to rewrite this thing so that it has only sine in it. Okay, that's it. And we need to get rid of the tangent and the secant in such a way that there's nothing but sine left. And you might ask, why do we want to do that? No reason. It's just, this trigonometric identities means beating stuff around. And once we get the sign, maybe a different problem says, take this equation and turn it back into tangent and secant. So anyway, so right now our goal is to beat this thing into having just sine in it. So let's do that. So this equal to 2. Tangent already have some sine in it, right? Because tangent is equal to opposite divided by adjacent, or sine over cosine. So let's write that down. Tangent equals to sine theta over cosine theta. And then secant is, we'll write it back as secant is 1 over cosine. So let's write that down. Secant equals to 1 over cosine theta. So we have one sine, but we have some cosines in this expression that we need to get rid of. We'll rewrite this thing as sine theta, and then and divided by cosine squared. Now, how does cosine squared relate to get rid of cosine squared in some way and turn it into a sine? The way we do it is by Pythagoras theorem, which says sine squared plus cosine squared equals to 1. And because of that, then cosine squared then equals to 2 sine. The top is still 2 sine theta. Cosine squared then equal to 1 minus sine squared theta, because sine squared. See, cosine is exactly this, because then cosine squared plus sine squared equals to 1. Okay, and that is actually the answer to this thing. So you can see that this is a pretty short and sweet question to do. That's example 5. Although trigonometric identities can get quite tough. Okay, but right now we're just doing the early ones, so they mostly should be pretty short and sweet. So next, let's do, what is that? Verify this complicated looking identity. All right, so let's do example 6. Let me write it down. All right, so I have the problem 6 on page 808 written down right here. We have sine squared, and there's a whole bunch of negative thetas in here. Look at that. And minus cosine squared, and then sine minus cosine. Okay, first you notice there's a sine squared minus cosine squared. That's the difference of squares. So we can write it in this form to fix something. And then secondly, we need to get rid of all the extra negative signs in here. First, we know that with cosine, if there's a negative sign in there, we can just ignore it. Okay, just turn it into a plus. Because cosine are the only functions that's even. And with even functions, you can throw away the negative sign inside. And then what about sine? Sine is an odd function. Okay, so if we get rid of the negative sign, then we have to put it outside. But what about sine squared? Well, when you take this negative function and put it out, negative sign and put it outside, it will get squared and turn positive. So we can just throw it away too, and not worry about it. So then now we have this situation left. So let's rewrite this thing to make it a little better. So that would be equal to sine squared theta minus cosine squared theta. Okay, and then what about the bottom? This becomes we'll factor out the minus sign, so that it becomes sine is inside sine theta and plus cosine theta, because we have taken out the negative sign and factored it out in front. Now the sine squared minus cosine squared is equal to sine plus cosine right here, and times sine minus cosine. This and so that means that the plus part gets canceled out with the bottom. So because there's a sine theta plus cosine theta at the bottom, so then we have only the negative one left, and also the negative sign. Okay, so the answer, and since the plus one got canceled out, we have the minus one. So the answer is minus in parentheses, because the negative sign still stays. In parentheses, that sine theta minus cosine theta, and that would be our answer. And that answer can also be written as cosine theta minus sine theta, because of the negative sign in front. Now that I've said that, let me check the book to make sure that I didn't make a mistake. Okay, let's see. What's this? Example 6. Cosine theta minus sine theta. That is correct. All right, so that is how example 6 is done. So next, let's look at example 7. Let me write it down. So next, let's look at example 7, and I didn't write down the page number. It's the same page number. It's the same as example 6. We're still on the same page. All right. So then, so we have a 1 minus cosine squared. What is 1 minus cosine squared? 1 minus cosine squared is equal to sine squared, because sine squared plus cosine squared equals to 1. So this is sine squared x, just this part. Okay, and then what is 1 plus cotangent? Well, from sine squared plus cosine squared equal 1, cotangent is cosine over sine. So this is so if you do cosine squared real quick here to remember what this formula goes, that is the formula says then this formula says that sorry, I wrote the wrong thing. Let me erase that. Now the formula says that if we take sine squared plus cosine squared equal to 1 and divide it by sine squared, then we get 1 plus cotangent squared, because cosine over sine is cotangent, equal to 1 over sine. 1 over sine is secant squared. This is one of the formulas we mentioned in the beginning of this video. So we're good, which is that thing, okay? So this part, 1 over cosine, 1 minus cosine equals the sine, 1 plus cotangent equals the cosecant. So let's write that down, C as C squared x. And then so we have, so the original equation now get turned into sine squared of x times cosecant. And what is cosecant? That equal to sine squared x. And then cosecant equals to 1 over sine, okay? So e times 1 over sine squared x. That's cosecant squared x. And so that equals to 1. And that is how problem 7 is done. But that is not the only way. Your book probably have a different way of doing things, because trigonometric identities usually have various ways of doing the same thing. And so, yeah, so your book did something somewhat slightly different, which is fine. And but we got the same answer. That is, A equals to 1. So let's look at the next page. Next page, we're going to look at, what is that? Let me look at it first. Now, example 8 on the next page, we have to, I'm not sure what the point of this is. I guess it's sort of a baby step to do something. Example 8 just says that you should write down the expression on the other side, where is the 2 cosine squared theta plus cosine theta minus 1. Write it in terms of x by substituting cosine theta as x. Well, if you did that, then it would be this equation right here, and in fact, it even can be factored into this. And that's all they want you to do. So we'll stop right there. Okay, that's example 8. Example 9, the same thing. If we have some situation where we have 4 cosine squared theta minus 1, that is a difference of squares, because this is a perfect square. This is 2 cosine theta squared. Okay, the 4 cosine squared theta. So this is, and then 1 is also a perfect square. So then we follow this formula right here. Then we'll be able to write down it being the difference of squares. So it's the minus 1 and then the plus 1. And that's about it. That's example 9. So next, let's simplify. Let's look at example 10. I will write it down. Now, example 10, we have cosecant squared minus cotangent squared. Well, we just said right here, see, cosecant equals to cotangent plus 1. So if you have cosecant minus cotangent, stick this thing on the other side, that would be equal to 1, right? That looks okay to me. Yeah, so the answer should be 1. Yep, that is what it says in the following page. Okay, a one-step job. And we have, as at the end of this, then we have come to the end of this section. Now this section, I plan to have a lot of homework, but I haven't assigned it yet. So I will do that in the next section. In the next video.